All right, so we have a couple things in the front of class today, and if you did the reading, some of it might make sense. But today we're going to talk about a kind of combination of vision systems and some of the phenomenology or the subjective understandings that we had from the first week. We're going to combine those two together, and we're going to talk about what a sense of ownership over your body is and how that extends to places that might not be physical, or if some of those sensory inputs are not organic. And so I think that for those of people, like maybe Dallin, you said that Matrix was your favorite movie, this could be potentially a topic that allows you to think very philosophically about what a sense of self-ownership is. If you're somebody who's a little, math is not really your thing, and you're not like in love with the camera, the way that some of us in the class are, this could be a really good topic to kind of break forth from for the class, right? Especially if you consider yourself to be somebody who maybe is not going to have as much fun when we get to like machine learning algorithms. So I've tried to put a lot of references embedded, as always, as hyperlinks into this lecture so that you can get on the syllabus and you can start doing like kind of a lit review as we move through, and you're not totally just staring at Google or getting on something like JSTOR, which is not a good fit for this class and trying to find things. As always, a pretty crappy PowerPoint, which I love. All right, so let's do just a little review. Try to do this every class. Last time we met, we talked about vision systems. Of course, we were framing this from the idea that vision systems are unique. I think they're very dominant, not only in human perception, but in digital culture. And they're increasingly something that are sometimes not organically construed. We're using cameras, and in fact, the camera is based on the camera. So we took a look at wavelengths of light. We talked about the electromagnetic spectrum. We found out, not surprisingly, that we can only see a little narrow part of it. And we discussed what that means in terms of qualia, perception. But we jumped into some rudimentary understandings of how we calculate wavelength and what a wavelength is, and that's going to be very important as we move forward in this class to discuss how we not only perceive things in the world, like phenomenologically, but also how we design systems for things like object recognition or change detection, tracking change over time, because we're often, if it's a visual phenomenon, which many things are, we're probably going to come down to some combination of wavelengths, but also features on what a pixel level. So we then complicated that idea a little bit by thinking about the fact that the light is not just happening in a vacuum in space, it's coming into our world, into the atmosphere. We talked about refraction, which is the fact that wavelengths of light are being bent, right? Which I think you had mentioned a mirage before. That was a really good example of that. We also talked about kind of line of sight and how things can seem distant and not where they are located in space, not because, just basically because of this change as light goes through the atmosphere. We also talked about reflectance, the fact that when we're viewing something, whether it's its color, its location, that light is what we're seeing as a color is light that's being bounced off the object, right? And we talked about some applications of that. And then we made, the last kind of thing we made complicated about light was the fact that we also have to factor in when we're talking about color, about the general ambience or the spectral power of the light, whether it's the sun or an LED, right? We had some pretty interesting questions when it came to things like reflectance, how much is being absorbed or reflected by a given object. I said that metallic things typically have a higher reflectance value. And we got really into the weeds, but we had some fantastic questions. I brought up the idea that the sunrise and sunset, the way that that color changes and the relative position of the sun is largely based in this combination of refraction and the change of the kind of spectral hues. So the sun is in a different location. Then Ashford, you asked about the northern lights, probably because we've seen on the news, and I said, I'm not really sure, but I'll get back to you. I did a little more research. I've hyperlinked in, and that it is very much related to what we talked about last class. So there's something called solar wind, and if you want a really clear account, you probably need to talk to one of my colleagues who's a physicist, but there's a lot of radiation coming off the sun in the electromagnetic spectrum, and what's happening when you see the northern lights is some of that radiation is making different atoms in the atmosphere glow so that they now have they're now reflecting portions of light that we can see in the visible light spectrum. So it's mostly like oxygen and hydrogen, things like that, and the color is how far away in the atmosphere that reaction is happening. So that's interesting. I like learning things. Then we talked about some applications of, once we understand this combination of how light is a wave, that we can begin to do things like reconstruct space with LiDAR and mapping. I have posted the last lecture for us, but it's not publicly on YouTube because we talked about some things that I'm actively contracting on that I'm sure that that people would not want me sharing on YouTube, right? So it's available for you, but it won't be posted like for everybody on YouTube. After that, we talked about, well, for us, how is this interaction? It's not just physics here, right? And we talked about our eyes being basically a filtering mechanism. And I told you we're basically setting up the idea that for a camera, in terms of object detection, computer vision, we're often doing we're building up similar systems. And some of you might have realized that you might be a little color deficient. Of course, we went back to the idea that in digital culture, a large part of the project has been trying to approximate human organic systems cybernetically with things like artificial neural networks. And this was the first inkling that we got, I think, that was applied that you can start to do this, right? When you understand what wavelengths are, you can break a color image down into its specific kind of different waves of red, green, and blue, and then begin to extract features like the outline of SpongeBob, and even start to match. Like, this is a very simple template matching algorithm. This is a very similar algorithm to what you would see if you, for instance, went to an airport and they took a picture of your face and they realized it was you, and then you didn't have to give someone your passport, right? We connected that back to the idea that a large part of, the 21st century and the later parts of the 20th century have been drawing from this idea that people like Rosenblatt and Marvin Minsky, who was cited quite a lot in the reading today, were trying to build kind of the artificial brain. Then we looked at the eye, right? We talked about pit eyes, complex eyes, corneas, and we kind of ended with the idea that maybe the human vision is a very complicated eye, but potentially this combination of cones and rods and all the various nitty-gritty things we got into last class, that there's the potential that the brain evolved after the eye, right? Because there are certainly many organisms that have those very simple types of eyes that don't have brains, or what we would consider to be brains. We talked about the fovea, the blind spot, and the relationship between rods and cones. Do you remember the difference between rods and cones? Can somebody help me out here? What do rods do?
That's like for peripheral vision, like
Yeah.
identifying, like not the details, but just like kind of what's there.
Monochrome, don't get eaten, see things, and you're exactly right. That happens in the peripheral. But then what are cones doing? Color, and they're kind of located kind of in the fovea. This will be really important when we look at how digital cameras are created with different types of filters. And yeah, of course, we're always bringing it back to this relationship between location and vision. I did such a long review today because that was, I think, we dived way into the weeds last class about human visual systems, and we're going to extend that today. So is there any question that you have from last week or last time we met that I can answer for y'all? We're feeling pretty good. 5 means like I'm ready to go. I have no questions. Fist means I'm a little, okay, so we're good. We're good. Yeah, I like that. All right, of course, you see this slide like every week. A large part of this project in this class is thinking through, is there going to be a meaningful difference as we continually replace the organic with the non-organic? So let's get to it. We have to do a little bit of review of Nagel, I think, just to make sure we're on the same part. We've got Descartes up here, right? Mind-body dualism. The reading today basically comes out of a tradition. I mean, I wrote it, but it comes out of a tradition that is very much separate from Descartes, right? And so can somebody remind the class what mind-body dualism is?
Is that when the mind and body are working like against each other? Not against, but like, not together.
Not together. There's a fundamental difference between the perceiving thing, the body, and the mind, right? And that goes back a long kind of history in Western philosophy to assume that there must be some difference. And a lot of embodied perception and embodied phenomenology, cognitive neuroscience is not, it's trending maybe a little more towards these things, right? It's reducing them, but also acknowledging that there are some things that probably cannot be reduced. So it's this weird kind of middle ground between these things. Qualia, what is qualia? What are the likeness, the subjective qualities? What is it like to be? And we've looked at bats, and we've realized that we probably can't anticipate their type of conscious experience. Like, we can't be experienced in a Hendrix way in a manner that's similar to a bat. And so, yeah, exactly. Qualia is that likeness of being, and it's derived from the inputs. I like to think of this, I don't like to reduce everything to just like mathematical notation or logical thinking, but here I really do think about what are the inputs into the system, right? And those inputs are probably going to change conscious behavior, a sense of ownership. Ownership is going to be huge for today. Like, there's a difference between having a hammer, driving a nail with the hammer, and having a tool, and then being like, the hammer is part of me. It is me. I am the hammer is me. It's hard to really even think about a situation in which you would extend a sense of ownership to a hammer in the same way you would your hands, right? And we're going to think about, like, can we do it? And I think there's some evidence that we probably can, if some certain conditions are met. Of course, this is one of the other slides we're going to look at a lot throughout the semester. This is exactly what we're setting up in today's reading. Can we do things like this and have it feel more like this than that, right? I think you're hard-pressed to say that if you're using night vision that you extend a sense of ownership to the night vision goggles in the same way that Neo is extending a sense of ownership over his hallucinated sense of self in the Matrix. I want to start with just a really quick video to kind of ground you, because I think a lot of times we talk about these things and you're like, yeah, but this might be kind of far away. This is from a student who just graduated last year. He's really into something called Gaussian splatting, which is a type of reconstruction of 3D space. We'll talk about it a little bit today, but we're going to jump into it like week 6 or 7. This is him creating virtual reality experiences right around campus. So you wear the Oculus, you run around, and you're kind of there. I think it's cool. I think it's pretty good work. You've probably, I mean, it looks like a video game, right? The difference being that this is, it's lagging, our internet is lagging a bit. The difference being that this is a physical place, right? And you have some video games that I think play with this concept. Fallout is one where you can often find like real cities on the map. But this is, we're starting to get to something where there's like supposedly a one-to-one relationship between the real world and our virtual world now. It's a little different. So let's talk just really quickly about how that 3D space is reproduced. We This is a thread that we pull on quite a bit this semester. We started it with Wormel, and we said, well, Wormel probably has trouble looking at 3D space. And I told you about a nifty little algorithm called structure from motion, which basically, if we know the viewpoint of a camera and we have multiple viewpoints of an object, we can begin to reconstruct that 3D space. Essentially, what we're doing is we're making something called a point cloud, which is a bunch of points, and then we drape like a colored texture over it, and now you have a 3D model. And you can put that into VR, you can do all these kind of things with it. So the simplest way to do that is structure from motion, still used a lot in self-driving. The thing about structure from motion is you can do it pretty quickly, but you can't like render it quickly in a VR experience, right? So we're really looking for something that'll be a bit quicker, just like what Andrew did, where you can move around and it's able to render that new space in a way that doesn't look bad, that looks like perceptually like real life. The next step here was something called a neural radiance field. This is a neural network, just like we talked about Rosenblatt and the perceptron. It's just a bunch of them. And what we're doing here is we're taking those images from different angles here, and there's a nifty little equation that is trying to basically decide through a neural network what should the color of that 3D space be and how transparent should it be. And we're not going to talk about the math today. And it's, I think for the 2, possibly 3 of you, that's something that we can talk about in office hours ad nauseum. But the newest idea here is Gaussian splats. This will be week 12 in the semester. And for those that are kind of mathematically inclined, it's pretty interesting. They're taking a covariance matrix. So that's like some basic linear algebra, right? And they're using that to basically, in a way, decide the transparency, the size of the point in the quote-unquote point cloud known as a splat. And that is a much faster computational thing to do and allows you to start being able to render 3D space in real time, which is like the dream. You won't be able to have a sense of VR that really is like real life unless you can render it in real time, right? That makes sense. There's like, well, I have to wait an hour to move into the next room. You're going to start to lose a sense of being there or a sense of place. And of course, real-time splatting is a huge, huge thing now that people spend a lot of money trying to substantiate, because the idea is that if they can, then a lot of these conversations that we've had about implications for digital culture will be kind of foot on the gas, right? If we can really take a virtual space and make it one-to-one with a physical space and render it in real time, now there's serious possibilities that we could substantiate some of the same feelings that you feel now. This is like getting to the idea that like, do I live in a simulation kind of thing, right? Ashford.
I'm curious why they want to like make virtual worlds. Like, what's the point, I guess?
Yeah, I think like making money, always a big thing in our system.
Like,
but
what are they going to do to make money, I guess?
Yeah, I'll give you a couple examples for the work I do, where being able to render virtual space is incredibly important to make money. So the first would be like infrastructure assessments, right? If we're looking at like a nuclear power plant, if I can, from a remote perspective, accurately map the inside of a silo, for example, in a way that doesn't harm a human, and then for that inspection, be able to allow the human to enter a virtual place to go through and look for cracks or fissures and then mark those, that's obviously pretty useful, right? Or potentially, I want to be able to just render out a huge space with maybe an elevation model from LiDAR, and then look for certain places when the construction company was, building that new big skyscraper where things are off, right? Infrastructure mapping and assessment is a place where this is probably going to be the future, and it's very easy to see how not sending a team of people out to physically walk a space, but being able to walk it virtually might be helpful. Does that make sense?
Yeah.
And then there's, of course, gaming and all these kind of things. But even the idea, the reading talks about this concept of telepresence, which we're going to talk about, this idea that you're not feeling that you're there in a virtual space. You don't feel like the things you're operating are yours. They're not your extension of your arm, but you're using them to accomplish things. In 1980, that was like way far out, right? We're going to look at some really like silly looking photos. Now, if you go in and you have brain surgery, that's largely what is happening, right? The surgeon, many times with more intricate surgery is no longer using their hands, right? They're using a robotic system that they're guiding. So yeah, let's get into the reading for today. It's about a decade old. It kind of blows my mind. But yeah, we need to think about the concepts of being there and how that is related to our senses. We've done a deep dive into vision, and today we're going to still be talking about vision a lot, which is why we started last on Tuesday talking about vision. But we have to actually look at a lot of different senses besides vision. I mean, that's one of a lot that we have going on here. So we'll talk about taste. People have a good sense of what that is? I would hope so. Vision. We covered it a lot. Smell, we good? Vestibular, balance. Is there a relationship between balance and any of these? What? Like is it related to smell?
Visual.
Visual, okay. Hearing, is there a relationship between balance and hearing? Yeah, there is. And then, okay, somatosensory, the sixth sense. Whoa, there's a lot there. We're going to focus largely on equilibrium and proprioception, which I've said a couple times is your ability to know where your limbs are in space. The idea here is that if we really want to authenticate a sense of being there in another space, maybe with like inputs into this multisensory system that aren't organic, we have really, really got to pay attention to what the inputs are and how we combine them together with our brains, right? So, right in the first page, I drop a term called an efference-based forward model, which you're probably like, I'm not going to Google that, but I don't know what that means. I've hyperlinked an article about it. That is a basic understanding that when you are authoring motoric action, where you're doing things, you're grabbing things, drinking coffee, playing the guitar, that you have this kind of model in which you have a predicted kind of action that you're going to undertake, and you're evaluating how accurate that thing is as you're doing it, often subconsciously, and it becomes like a feedback loop, right? I'll give you an example of something like this. Have you ever walked up a flight of stairs that just wasn't built right? Like the rise over run was not right. Like it was not a real carpenter or contractor who did it. It was like your Uncle Bob. And you're like, something does not feel right, right? Or maybe growing up, your parents like redid their bathroom and the faucet height's at a different level now. And you find yourself like, oh, wait, no, I'm here, right? Or maybe you had one knob to turn on the hot and cold water, and now you have two. And you find yourself doing these things, and you have to kind of readjust. And what's interesting is that we can readjust pretty quickly, right? Give you a week of shitty steps, and every step that you walk up is one of these poor rise over run calculations. You're going to adapt to it. And then when I put you on normal steps, you'll be kind of like, whoa. An efference-based forward model starts to try to understand why that's the case. Because you're getting some kind of sensory inputs, and then you're interpreting them, and where there are mismatches, right, where your feet kind of hit the step where they shouldn't, you're making some slight adjustments. And the question is, what are those adjustments? And we're going to look at a couple theories of what they are. And here, of course, in this course, we're also always thinking is like, so if we understand how the biological system works, is there a way that we can duplicate it in a non-biological space? And I want to be completely upfront and honest. Today's reading is going to touch on a number of theories. There's a lot of like theories why this might happen, and our psychologist friends in Poly might have competing theories, but some of this is like very hard to empirically prove one way or the other. But usually when we find evidence, it's like fascinating. So the Cyborg's dilemma, it's in the title of the article, and this is the kind of question that a theorist called Bayaka asked, over 20 years ago, I guess 30 years ago. It says, like, if the experience of being there is determined by the type, the quality, the integration of different multimodal things, what happens as we start to replace them, and specifically as they are replaced and we adjust to that, right? We start to really adjust to the non-organic multimodal feedback. Is that something that comes with like hidden side effects for the real, like, fleshy, organic experience of being in the world? Does that make sense? What do you think about that? Do you think that's like something that could happen? Yes, no, maybe so? Real quiet. I know it's Thursday, but shit, we're quiet. Yeah.
I think the brain's ability to adapt is something we've talked about a lot. So I guess it depends on like the severity of the technology that we're changing with the body.
Yeah.
So there's a potential that we can adapt and it becomes part of our everyday life. I think about people that have like lost limbs and they get like,
we're going to talk about that. Yeah.
Start to get used to that. It's obviously not the exact same as having your own arm, but we've certainly seen like some examples of the brain being able to change.
I think it's hard pressed to be like, no, it's bad for that person that they have a robotic arm and now they can substantiate a sense of being there that is like hopefully somewhat similar to what they accept as normal for them, right? But I'm going to read specifically, this comes from page 11 in the article. The embodiment advanced in a form of virtual environment technology can be characterized as a form of cyborg coupling. He's talking about organic and inorganic. This coupling underscores what I call the cyborg's dilemma, a kind of Faustian trade-off. Faustian trade-off means like you get something but you lose a lot there. It comes from an opera, a Deal with the Devil. So a kind of Faustian trade-off. Choosing technological embodiment to amplify the body is fine, but be aware that your body schema and identity may adapt to this cyborg form, right? And body schemas might be some terminology we don't know. We're going to learn what that means, but he's basically saying be careful, right? And the question that we need to ask ourselves is this just somebody writing 30 years ago who doesn't understand? They don't understand how plastic we are in terms of being digital natives, or is he onto something that we really need to consider and think carefully about? So let's talk about types of being there, because of course it's more complicated than just being like, yeah, I'm there. There's social presence. We're not going to cover social presence. Social presence is like, I'm there with my buddies in virtual space, we're playing Fortnite, or we're in this virtual environment, and we kind of all feel like we're together, right? That's cool. I think we know that happens. I know that we have like entire parts of digital culture now that are based on like parasocial behavior where you identify with somebody you've never met. I don't think we have to spend a lot of time talking about this. I think we know it happens, and I think it has very little to do with like a sense of you being like, that robot arm is mine and I am that robot arm, right? Physical presence, that is bolded here because that is something that we do have to consider, because it might be an on-ramp or an on-road onto this idea of self-presence. So physical presence means that you feel like you're physically present in the situation, but you might not extend a sense of ownership, right? So you're using that robotic arm, but you're not like, that robotic arm, I'm worried about it. I'm worried that it might get crushed and that might hurt, right? And if we really have that coupling where you're afraid that, that robot arm might get hurt and then you're going to get neurons firing for pain response, whether that actually happens or you kind of hallucinate it, that would be, I think, what Bayaka would call a full series of sense of self-presence and being there. So being there, like everything, is kind of a continuum. So physical presence. It starts with Minsky, 1980. His concept of telepresence. And this is like, I love, there's something just like really great about this like 1950s, we can go to space, we can do everything kind of aesthetic. Like the world will be solved through science. And a lot of people were spending a lot of time trying to substantiate an experience of, hey, I'm there, right? And they made some like really goofy apparatus. And what they learned is that it's definitely not a sense of ownership, although I think, to be completely frank, they were trying to do that, right? And that sense of, hey, I'm there in the moment, works best when there is proprioceptive and haptic feedback, right? So it's like there's a one-to-one match between how the robot's arm moves and what your arm is doing, right? And that makes sense. I don't think that's like mind-blowing. And yeah, there were a lot of people were already thinking about robot surgeries, which is something that happens now. They were thinking about these like, these kind of like robotic systems that would allow you to work in a factory and lift things up heavier than you can. And of course, the ways that we can make things safer in things like nuclear facilities, right? Questions, comments? This is a picture of Martin Minsky, and what a dude. Okay. A couple things about physical presence that might be a little surprising, though. We talked about it works best when there's a one-to-one relationship. So if my arm can only move this far back, if I make a robot arm where I can do this and it keeps going back, I might be a little bit like, yo, something is weird here. And visual systems are probably the best instance that shows this. So this like terribly weird looking thing is one of these like telepresence robots. And they found that physical presence can happen regardless of the scale. So let's say that you lift up like a 1 pound weight, but then the robot is able to lift up like 1,000 pounds. Your force of perceived exertion, we're basically scaling up your strength. That you can still feel like you're physically present, even if that scale is off. But it works a little better if it's one-to-one. Make sense? And more so than the scale, it's that low-level control is best. And what this means is that instead of like telling ChatGPT, move that box, right, which GPT can't, but instead of telling a robot system, move that box, you're not going to feel like you're there the same way that if you have to physically manipulate it moving over with a series of joysticks. So low-level control is really something that's important here. And you could do it in some weird ways. So the telepresence eye was this thing where your head is in here, and as you turn, you don't turn in a one-to-one relationship, right? What I mean by this is like we are not owls. We can only turn our head about this far. But the ratio between like a angle of movement here and an angle of movement for the visual system was not one-to-one. So by turning this far, you could like turn 360. And what they found is people can adapt to it, but it does cause a bit of nausea, right? Is that surprising?
No.
No, why?
You're just never used to it.
You're never used to it, yeah.
Your body just isn't like adapted to like that kind of.
Yeah, and we're going to talk about how that adaptation works. It's actually way more complicated than just like, hey, yeah, no, I'm used to it. But you're exactly right. It seems alien in some ways. Do you think that the more you did it, though, you would no longer get sick? Part of this is like, when I asked students this 7, 8, 9 years ago, that was not the answer. People are like, I don't know. I think part of it is the type of media experiences that you have had where you've seen and done this thing. Yeah, there's a lot of, it's very much up for debate whether the human body could adapt to something like that. On the one hand, we adapt to steps pretty easily, and I think that's why we can adapt to these experiences. But physical presence, telepresence, that is not a sense of ownership. And the sense of ownership is kind of what we're chasing here. So self-presence can be defined as not that I'm there, but this is me. That's a pretty big difference. You're here in the moment. You're wearing a jacket. That jacket is not you. If we can get it to the point where you feel like the jacket is you, we've done some pretty cool biohacking. I don't know if it's a good thing or not. I'm not making a normative judgment. I'm just saying that like anything like rhetoric, like communication, like great power comes great responsibility. The robot hand for someone who's gone through amputation, awesome. You can easily think of some scenarios in which this is me for a concept of self-presence with non-organic sensors is could be very problematic. It's one of our favorite words as professors, problematic. So related to it's going to be related, of course it has immense applications for VR, but it's related to the sense of body image and schema. And I'm not talking about like, I'm pretty skinny, I need to go lift some weights. Not that kind of body image, but the kind of body image that your body takes in order to author motoric action in space. And that's a complicated sentence there. Do folks understand what I mean there? What do I mean there then? Yeah, that the body.
How long your hands are?
Yeah, that efference-based model, right? This kind of feedback loop, that there has to be some kind of, if it's a feedback loop and you're making knowledge about how you are in space and what you can do, that there has to be some enduring kind of reference to that, right? Of what you're capable of, what you can do as a human, and how that might be a little different, right? If I was 7'1", which I am not, I probably would be in the league, hopefully, but my body image and body schema would be quantifiably different, or maybe not quantifiably, it might be hard to quantify, but it would be different than if I was my height or 4'10", right? All right, so how do we know this? And this is like, we're really starting to tear apart this idea of the Cartesian body dualism here. This is why he's on this slide. We do a lot of experiments with monkeys. Some of it's not super great. But we do things like we map their brains and we see like when they're using tools for a sustained amount of time, is that going to change their concept of like kind of a body image or schema, right? I think if any of you play guitar, you play an instrument, this is something where if you have like one type of, say you're finger picking and then you move to a pick and then you use the same pick for a year and then you change to like a different weight, a different size, all of a sudden things are like a little harder, right? You kind of have to adapt to it. The thing here though is like that's definitely a type of embodied cognition, and it's drawing from your sensor motor capabilities, which in this case you're like not as good as you were. Or like a different golf club, a different size bat. And it's definitely rooted in you having a body, but I don't think we extend a concept that is your body image the same way that we could talk about if you lost one of your hands. And again, that comes down to a sense of ownership. So, Briscoe, 2014, this is who I learned this from. He's a very interesting philosopher doing a lot of work at Ohio University. He's drawing from a tradition where he says the body image is great, the sense of ownership is important, but really what's important is a sense of egocentric space, right? Let's like try to think about what that word might mean, egocentric space. What do you think that means?
Like my space?
Not just like my space, like personal space. Like if I got into your personal space, you feel weird. I'll give you
Space of yourself, I guess.
Is it like your perception of how much space like you have?
Yeah, so I would say lat-long coordinate system, latitude, longitude, not egocentric space. The Cartesian coordinate system, not egocentric space. Does that help you start to piece together what this might mean? So I'll just break it. Yeah, Evan.
Having like an anchor in your space?
Yeah, we're starting to piece it together. Yeah, it has to do with kind of an anchoring mechanism. It has to do with it being yours. It was egocentric. Yes, Ashford.
Question about the monkey.
Yeah.
So on the last slide, there was like the monkey using the tool and then the monkey not using the tool. Does its brain, like, once it learns to use the tool, dedicate like more energy to like remembering?
Yeah, well, we're going to touch on that a lot in a bit. Here, I won't like play this terrible game where you have to anticipate things you haven't learned, right? So, non-egocentric depictions of space are on objective coordinate systems. So north and south is one. Egocentric are things like it's to my left or my right, right? And there's a lot of, I mean, that's a very simple concept, right? It's to my left or my right. It's above or below me. But how your body, and it's something that, quite frankly, a lot of like artificial intelligence with robotics is trying to figure out how to do that. Because even though it's incredibly simple to say it's to my left, to say that something is to your left is to know that you have ownership in your body, you're in place. And how the hell does your brain do that? Right? Any ideas? Well, one that Briscoe is really into, that I find maybe plausible, is that some of it has to do with your fovea and your visual line. That at least you could make the things that it's above or below me based on a lot of the stuff we talked about in last lecture. So that might be part of it, right? There are a lot of theories. Evans says that it's based on this longer kind of efferent feedback loop of what your body can do and not do, what your limitations or your affordances are, and that kind of filters in. That seems like heavily theoretical, and then some folks were like, yeah, that might be cool, but let's like root it in actual things. Bermuda says it's the apex of your visual field. That's similar to what we just saw there. And then folks say, yeah, but that would seem to say that you would have a good concept of egocentric space if you just were like fused like this and you walked around. And that might not be the case, that it might actually be a relationship between the visual field and your torso, right, as you turn your body. And then sounds like, why don't we put it all together? It's like twisting your neck, your body, your eyes. This seems like might seem silly that people dedicate their careers to trying to figure this out. Like, how do I know that something's to my left of me? Was this combination of the torso, the neck, and the eyes? But really, when you get down to it, a lot of what we do in the academy is that we think through these very granular things because there's not a lot of money in it. But if you can figure it out, you might be able to provide information that will accelerate a lot of things, right? A lot of times, like if you go into the private sector, there's like no one's going to pay you to think about this, but people want this to be solved because once you can do that, well, now we can think about robotic systems, stuff like that. So yeah, these are a couple just kind of depictions from different articles about how we can come to a sense of egocentric space. So this one's torso and the neck. This one is torso and vision. And then, of course, why this is important in terms of what we're talking about in this class. Questions, comments? Does this seem like incredibly simple? But also, it's like it seems simple, but the more you look at it, you're like, I don't actually know how I know that something is to my left, right? And if I made you break it down into like a kind of like series of logical axioms or an algorithm, you wouldn't be able to do it, right? And maybe being able to do that is a key to a lot of senses of ownership. So yeah, we definitely have a concept of egocentric space. There's no question about that. There are some people who might not, and that often comes from things like tumors in the brain or carbon monoxide poisoning. So we know that it's definitely a cognitive phenomenon, and we know that most people have it, but we also need to think about how it's constructed from the ground up in terms of the different sensory applications that we kind of put into our input system. And what we're really looking for is trying to make visible this invisible subconscious system that gives us a coherent sense of self. And of course, if we can do it, if we can figure that out, we might be able to figure out how to give other forms of life is such an interesting word, but I'll just say other life forms the ability to have similar perceptual experiences, and maybe we'll start, as Bianca says, blending those two things. All right, so one of the most useful ways, we get these like little junctures, these little points in time where usually a perceptual psychologist or a neuroscience like makes this discovery, and then all of a sudden we're like, oh shit, we'll put that into our model, and we'll understand that. And the body image and phantom limb pain as a phenomena gives us a lot of things to think about in terms of our body image. So, show of hands, how many people have heard of phantom limb pain before? You know that it's a thing? Well, hopefully everybody does after the reading. So can somebody explain to me what it is? Ashford?
An episode of House.
Yes.
Where a guy comes in and he fought in Vietnam, and like he was holding this kid's hand, and the kid got blown up and a bit of his arm too. Mm-hmm. So he came to Dr. House and he was like, my arm is still holding on to that kid.
Yeah.
Like he wasn't.
Yeah. And Ned, what were you gonna say?
It's like same thing, like war vets, I get like their bottom of their knee blown off, they can still feel like the nerves that don't exist.
Yeah, and it can be incredibly painful.
Yeah.
I mean, it can be a level of pain. I mean, pain is neurons firing, and if you have no control over the system and your nerves are firing, that could be conceivably some of the worst pain a human can possibly experience. And there's like very tough to fix that. Because you can't be like, yeah, take the medication for the limb that doesn't work, right? This is something that seems to be suggesting that, although we kind of were ripping on Descartes earlier, that there could be this difference between what the mind can perceive and what the body is bringing in as a sensory impulse. The body image, it allows you to do things like lift weights, right? You have to be able to have like a good, solid sense of your place in space derived from vision and proprioception and hearing in order to do something, like lift weights. So, and even some people, it's not kind of phantom limb pain, it's that they think that there are additional limbs there that never existed, and that's fascinating too. And it could be that we don't have just one body image or body schema, but we have a long-term body image that we accrue over our life, and then we have a short-term body image. So if I put a helmet on you, right, and we go out and we do something, let's say we're climbing, and I put a helmet on you, and you're climbing up the wall, and you're just like hitting your head on the wall because all of a sudden your head is now a little thicker because of the helmet. We've probably had experiences like this, new pair of shoes, something like that, gloves in the winter, you make a quick adaptation to that after a while. That could be updating your short-term body image, but you're never, once we take that helmet off, you'll be able to go back to kind of how things are for you. O'Shaughnessy talks a lot about this. So, yeah, if we know that we have this kind of model where we update what we can and can't do, and that the body image is not static, phantom limb pain seems to suggest that that's actually the fact that we can cure it means that we can update the mental models. And we'll talk about how it's cured, which is not with medicine. And potentially it can be extended to non-body spaces and non-organic entities. Again, phantom limb pain is an example in which, it's kind of a subtraction of an organic limb or an organic thing. And now if we can figure this out, we might be able to get to that idea of total telepresence or self-presence, the kind of dream that like that thing is you and I'm there. And this is perceptually, it might be different than the real world, but it's just as meaningful, right? Questions, comments?
So does it all mean the ability to understand how the brain and cognitive processes work is the key to getting that experience?
I think so. I think it's not just designing a better camera or a better haptic glove or a treadmill that allows you to run in VR, right? It's also understanding this relationship for how the brain interprets those signals coming in. And this is not just for like far out VR. This can be as simple as like making a better color grade for a film, something that's more in line with our perceptual experiences. Yes, Ashford.
So talking about like the short-term adaptation we make, like
Mm-hmm.
if you put a helmet on or something.
Yeah.
Let's say like, I don't know, you go skiing a lot,
Mm-hmm.
and like you're used to having the giant boards on your feet.
Yeah.
Is there like a point where like if you do it enough, it just becomes part of you, and like it's really easy to like get get back to it?
I think that to a certain extent, that's what talent comes from, right? I hate to be like Malcolm Gladwell, 10,000 hours, but like that, in some way, that's might be what's happening, is that you're able to not have to think consciously about the actions that you take, and they can happen subconsciously. Like a sweet swing in golf or baseball, the ability to play guitar with your eyes closed and just feel it. To some level, I don't know if we want to say that's a body schema or a body image thing, but I think you're getting to the point that we're starting to see some overlap there. And just really quickly, the body schema is what kind of produces the body image. So that body schema is that efference feedback loop between prior thoughts and then the sensory inputs that you're getting in real time, and we kind of meld that into a consistent sense, people think, that we can call our body image. And then we might have a long-term body image, and then a short-term body image that's much more adaptable, which allows you to wear like different styles of shoes or put on roller skates, do things that actually are. It's kind of weird to think of roller skates as a form of augmented reality, but in some ways it is. You have a new affordance of moving in the space that you didn't before. It's the same reason that you can like drive, quite frankly. And then you can come out of driving and not be like, whoa, what the fuck, I'm walking again, right? Yeah, so this is why these things are here today, and this is what I'm going to ask you to do as part of your participation credit. It's probably like the easiest homework you're ever going to do. Make you make an appointment with the rhetoric studio. They don't even know I'm doing this, so this will be fun for them. These two things will be here, and 30% of the population is completely immune to this phenomenon. It's not going to happen to you. We also have like varying sizes of hands and skin tones. It'll be interesting to see if we can substantiate this. But what you're going to do is you're going to wear my PhD robes, because that's like the biggest thing, probably backwards. And I need you to go ahead. There's a box in there. You're going to put your hand under the box, and you're going to put this rubber hand in the robe, so it looks like your hand right on top of each other. And you're going to have the rhetoric studio consultant, who's going to be like, what the fuck? He's going to take a pen, and he's going to stroke your real hand while he strokes the rubber hand for about 10 minutes. I know stroke is, I don't know if I had to use that word. For many of us, we will begin to have a sense of ownership over that rubber hand. It'll be very trippy, and you will begin to identify that as your real hand. And then, in fact, if I took a needle or a hammer and smashed a rubber hand and had an fMRI on it, the same parts in your brain would light up in terms of like apprehension of pain that we would get if I threatened your real hand. About 30% of the class statistically will probably be immune, but some of you most likely will have that experience. There's a discussion board where I need you to just post whether it worked for you or not, and then describe the experimental apparatus. So what exactly did you do? Because we're probably going to, this is like empirical experiment. Probably there are going to be some variations, and we can think through like, is it just that Bass is like, he can't do this? He's one of those 30%, or maybe it was because like he didn't do it the same way that we're doing it. Very easy way to get 2% of your total grade in this class. Does that make sense? It's also going to be fun for the rhetoric student consultants, because they're like, what? This is not a speech. All right, so that's a body transfer illusion, right? We are at self-presence. We have taken something that is really, in my opinion, just rubber, right? That's what it is. And now all of a sudden we think it's ours, right? We treat it like it's ours. We're worried about it in a certain extent. It's a body transfer illusion. And one in kind of an opposite direction, phantom limb pain, like we discussed, is a big problem. And the solution to it is something very similar. So instead of there being a rubber hand in here, what we're doing is using something called Ramachandran's box to train the long-term body image to adjust to the short-term body image, which is that you no longer have that limb. And that's actually been pretty empirically proven that that is the cure. It's not surgery. It's not some kind of like medication that changes the way your neurons fire. It's simply using an optical illusion to understand that you no longer have that limb. Really trippy, right? But kind of cool. And Slater in 2009 shows that there are a lot of instances in which we might be able to do that to virtual appendices. So we go back to those Minsky robots, Better Living Through Science, 1950s, 60s, 70s. And the idea was is that like you felt like you might be there, but you didn't own it. You weren't concerned about the robot. This is starting to get to a point in which, you might be. So this brings the idea of the progressive embodiment thesis, which is the idea that multisensory inputs can be progressively replaced with non-organic ones. And if we did that, could we have, substantiate a type of living in the world that maybe doesn't feel a whole lot different, right? Maybe it's like you're that battery in a vat in the Matrix, right? And you're not actually doing any of the things that you say you're doing or you think you're doing, but we progressively replace the stimuli with ones that are not kind of in this world, so to speak. We think this is possible? I don't know. I don't know. Yeah, you're saying yes. Hayden looks deep in thought, but he hasn't said anything. And Bass is doing this, which makes me think he's not. I don't know. I mean, this is why the cyborg's dilemma is an interesting question. Is it even possible, right? And that's why I start with us reading Nagel, because I think what Nagel might say is it might not be the exact same experience, and it might be hard to even anticipate what that qualia is. And really, if we use that terminology, what we're just deciding is could there be qualia, right? And even philosophers are really vary on what consciousness is. Yeah.
Do you think I was thinking about this when I was reading the reading, even if it's not a 1-to-1 ratio, if we were to create a virtual world, say a kid grew up only in that virtual world.
Brain in the vat, but brain in the yeah.
Would that?
I certainly think that it would be helpful. I think it's largely unethical and probably we shouldn't do it, right? But it sometimes when we talk about cybernetic or we talk about digital, we start to just be apprehensive that these things could happen. I think in the same way that we were apprehensive that, if we define humanity as tool usage, then other things couldn't use tools. And then all of a sudden when we found other species that used tools, we had to reevaluate what human meant. That maybe it wasn't homo faber, the thing that creates and constructs. So I don't know. I think I think we should probably talk about some people who are born with different perceptual modalities than us. And they might not be a little kid that was, conceived in VR, but they might, have different sensory inputs. And let's look at what it's like for them, and maybe we'll learn something about ourselves. This is a lot of disability studies looks at this, which I think disability studies is largely often very misinterpreted in politics writ large. A lot of this is thinking you have a lot of people whose sense of being there is very different than a wide variety of the population. And if we can understand what is different, then we can begin to understand kind of what that sense of being there is. Yeah, it's not a bunch of woke stuff, right? It's actually pretty important to a concept of humanity. So I think it's not up for debate that vision might not be where this is rooted, because if that's the case, then you get into some really dangerous territory in terms of blind people, right? But I think it's very clear that it is, if you have vision, that it is a very important input in that multimodal model, right? And so if we're looking at body image and a sense of ownership as an integration of sensory modalities, and we're thinking about the progressive embodiment thesis that we can change those inputs, and how does that change our sense of self, vision systems are going to offer us some clues. So once again, it's almost like this class's deep mapping and vision on its course title. We're going to talk about vision. Vision's tough. I think it's interesting that where you process it in the brain is actually pretty far away from where the eyes are, right? The eyes are like maybe down here. If you have like a big brow like a Neanderthal, maybe they're like here. But in any case, it starts with the retina, which we know what a retina is. We know even what a fovea is. And then we're going to move to different areas of the visual cortex, V1, V2. And what's fascinating here is that these different visual cortexes actually break apart the images into like sub-component parts and process that. So V1 does like edges and orientation. You see why that's important? It's almost like it's like a computer vision algorithm that we like have an image processing pipeline where if we want to tell if something's a dog, like in classic computer vision, that's what we do. We like we want to find what dogs are. We take it apart and first we detect the edges that might be doggy. And then we look at like the contours. Basically, we put those little doggy features together to get a sense of shape, and then we compare it to a data set of other doggy parts put together, and the algorithm learns to detect dogs that way. It's almost like our human brains do that a little bit too, which is, yeah, interesting. But there's one other kind of wrench to throw in the system here. And this is, I said earlier, we have a lot of theories and we have a lot of empirical evidence to support those theories, but there's a lot we still need to learn about how the vision works and how the brain processes a sense of self. Yes, Ned?
Is this like, this isn't the left and right brain stuff?
No, this is not the left and right brain. Although it does like happen on the left and right. And actually visions get crossed. Like if you go back here, you see how there's this kind of crossing. This is something that is pretty, on one hand, it's like egocentric sense of space. Once I explain it, you're going to be like, yeah, that does seem to be the case. But on the other hand, it's fantastically trippy. So the dual vision hypothesis, known, first recognized with some experiments with like different monkeys, and now we have some cases of people that seem to provide some evidence that this is the case. It's that we have actually two types of vision. We have vision for doing things, vision for motoric action, and that is subconscious vision. And then we have conscious vision, which is for perception, saying that that thing is a baseball. I like to explain this way. Let's go play some pool up at the student center, and you look at that cue ball and you say, that's a cue ball. I know it's a cue ball. The dual vision hypothesis suggests that that ability to recognize it is a completely different stream in terms of processing in the brain than for you to go pick up that cue ball. And if we were playing and I got pissed and I just whipped a cue ball at you, your ability to get out of the way or catch it, that is completely different than your ability to know that, to call it what it's called. Does that make sense? Yes.
So it's more like the motion is different from the recognition?
Yes. Yeah. And motoric, that we have a vision system for processing motoric action, doing things that is completely separate from our perception, our ability to know what the thing is, even where it's located in space. And that is creepy, right? So your ability to say, I think it's 10 feet away from me is completely different than your ability to walk over and then accurately pick it up. That, it seems like almost like how, right? Well, let's look at some examples. So what's the strongest evidence that the dual vision hypothesis is actually a thing? It's folks who have competing problems with motoric action and then spatial congruence. So optic ataxia is a fancy word for people who can totally describe that thing is 2 feet away from me. It is a rubber hand. I know that. But when you say, okay, walk over and pick it up, they're like, all right, here we go. Oh, here we go. Huh. I know it's probably 1.5 feet away from me, but yet I can't actually use it. I can't author motoric interaction. This is often caused by tumors over certain parts of the brain associated, we think, with that vision for action. Gödel talks about this in 2008. And of course they're doing things like they're putting people up, hooking them up to different brain scanners, and then having them describe things, say how big it is, how far away it is, and then go and try to manipulate it, and they have trouble. So if that is ataxia, which is that your vision for action is somehow not right, but your vision for perception seems to be spot on, what could be the other thing that would happen? The inverse of that.
You can like grab it and stuff, but you can't describe like how far away it is.
Yeah,
Like,
exactly. Yeah. In comes agnosia in a patient named DF. He's very famous in this type of literature. She had, unfortunately, some pretty serious carbon monoxide poisoning, and that damaged a portion of her brain. So you can see her left hemisphere and right hemisphere, there's like some pretty significant damage there. Yeah, get a carbon monoxide detector if you don't have one, especially when you move into your own place and you might be like heating with gas or whatnot. Do it, because you don't want this. Because she can pick up a quarter or a rubber hand, but she can't tell you exactly what it is, and she has no idea how far away it is from her. Yeah.
So she doesn't know how far away it is. How does she know? Like, how can she? Yeah.
I no, it's a fair question. Because maybe our vision system is split between motoric. Yeah, that's why the fact that you're struggling to reconcile this is really, I think, what's so important. Is it seems so alien and foreign, right? Like judging distance is intrinsically related to my ability to move in space, right? But also think about the fact that like that egocentric conception of space. That's why we started there. I think that's easier to understand. It's like, yeah, that's fucking simple. And then when we get to cases like DF, we're like, okay, I don't know, right? And so it's clearly something. It's a visual processing process in the brain, but it's related to our embodied cognition as well, to our perceptual sensory modalities. It's really, this is where Descartes might actually like come out of the grave and see, I'm onto something at least, right? And this is why that like mind-body dualism, embodiment, phenomenology, it's not like people are able to say firmly one is right and one is wrong. We just have these cases that seem to problematize different parts of it. Ashford.
For this patient,
yeah.
The reason she's able to like interact with stuff without being able to see it is because like other senses just make up for it.
Yeah, I mean that would be the case, but what would those senses be? They would be probably proprioception. They'd probably be balance and things like that. And those seem to be like, those are the things that are like, yeah, it's complicated because on the one hand, like if a sense of egocentric place was purely proprioceptive, because she obviously retains some proprioceptive knowledge to be able to manipulate the object. And it would be easy to say egocentric space clearly is a function of proprioception, right? This is like the head and the neck and the torso. But maybe it's not quite just that, because if that were the case, then she wouldn't have this problem, right? So it's tough. And then you got to start thinking, well, if you are interested in trying to do this with, first of all, maybe just like non-organic beings. You want a robot that is kind of able to do the same things. Well, how do you build it? And second of all, that kind of cyborg state dilemma and progressive embodiment, right? Yeah, it's something to think about. And then this is one that this comes from a computer vision lecture that I've linked, Redmond's Ancient Secrets of Computer Vision. This is a man who is legally blind. Right? So what his eye is bringing in, whether it's happening at the level of rods and cones and retinas or it's the processing, he is legally blind. And yet he can walk around things and avoid obstacles. And the answer to this is not that he's faking blindness, right? So how is this possible?
Is it the same feeling you get when sometimes you feel like somebody's watching you from behind?
Maybe.
They're actually watching you.
Could be. It could be. You said echolocation. We had talked about in that past class. He's not clicking. So it's not that he's like basically trained another sensory modality system to stand in for vision, right? Manning?
Could it just be like the vision system, how you said it goes from like V1, V2, V4? Could it be like it just pauses at like the first one where he can just see like edges or like a shape of something?
Yeah, I think that this could actually be something that potentially can be explained by the dual vision hypothesis. Is that he's blind in the sense that he has no conscious perception of the world around him, right? He's not able, like, whereas someone like DF has trouble articulating what that thing is called, the optic ataxia, difficulty articulating where it is, but you can still use it. This would look like that pushed to the very extreme. Like, that system is completely degraded. You have no ability to say, that thing is there, I know that it's there, it's a coffee cup, and yet, in terms of motor action, you're able to. You can see how, like, that, you'd still be blind in a sense, because if you don't have a conscious perception of the visual systems around you, well then you don't have a conscious perception of the visual systems around you. But that doesn't mean that you might not be able to author motoric action in a way that seems meaningful. And obviously, he's not walking through this hall the way that you and I would walk through it, right? It's very clear that this is like a tepid series of steps that we're taking, but it's very trippy and very fascinating, yes?
This might be a bit far out, but like, in conjunction with like being able to kind of see, could it be like something to do with the air, like how flies can like feel you're about to hit them?
I think this is kind of what Jackson was pointing out, was like, is it maybe echolocation? That I would say that would be an instance in which we are basically, and this is a known phenomenon, that people who have impairment to one perceptual modality, often their other perceptual modalities are heightened, or they develop these kind of shortcuts, right? And so if haptic touch-based feedback is how you have to do things, well, somebody who reads Braille arguably has a much different qualia in terms of how things, the touch-based thing than you and I do. We're kind of deadened in that way. Or if you've ever listened to somebody who's blind talk about how they enjoy music, it's about like vibrational frequencies, right? And that is, it's I think fair to say that they might be a little more attuned to vibrations in the world than you and I are. Earthquake hits us, I'm like, yeah, I felt that, but that's about where it is, right? Any other questions, comments? So this is something that goes way back. Stratton, and that should say 1896, not 1986. That is a typo. Man, that's terrible. He, as far back as the 1800s, folks were playing with this idea. So he created this like upside down glasses, basically, like a party trick. You can buy them off of Amazon. I'll probably buy some and then pass them out. You can try them. And he walked around his like flat or his apartment for like 21 hours straight with these on. So it basically makes it seem like you're laying down and you're seeing like just the ceiling. And he reported that, he was able to adapt pretty well. It wasn't the same kind of conscious perception, but he was able to do it. And we know this from gaming, we know this from playing sports, and people like O'Shaughnessy say, well, that shows us that we probably do have a long-term and short-term body image. That explains phantom limb pain, it explains the ability to do this, and then the dual vision hypothesis explains some of the things that we were just talking about. So, participation credit this week. I need you to make an appointment in the Rhetoric Studio. I want you to substantiate the rubber hand illusion, see if it's possible for you. I want you to post on the Canvas discussion board, which is already there for you, about whether it worked or not. Detail your experimental apparatus, photos, descriptions, what you did. And then there's a second discussion board. I know I'm making you do two things, it's terrible. I want you to let the group know what you found most interesting this far. Because part of what I'm thinking through is like what your final projects are going to be. And some of you, I'm meeting with you quite a lot to discuss these things. Others, I don't see quite so much. But when Dallin says, for example, The Matrix is his favorite movie, then I'm like, maybe this week and last week and the week before where he's going to root the project and not talking about drones and remote sensing. Or when we get to like what a Bayesian classifier is, he's probably like, I did the reading, but this is not where I'm going to spend my energy, right? So I need to start knowing what you're finding interesting. Yes?
When does this due?
Let's say this is due, because we don't have class on Tuesday. Let's say you're going to do this by the end of Tuesday.
Okay.
That would be helpful for me because when I'm driving back from Nashville, I will use a speech to text to listen to what you say. Does that make sense? Yeah. I promise I won't scroll while I'm driving. Because I think there should be a lot of snow, so I'll have to be extra careful. Does that make sense? Questions, comments? Interesting? Not interesting? Kind of very interesting. Yeah, I think it can be scary when we critically interrogate these things at the lowest level, and we talk about math, and we talk about physics, and we talk about cognitive neuroscience, but I think you get a lot more out of it than just sitting in a room being like, what is digital culture, right? It's like almost like to do that kind of close text analysis on something that is on text, you have to understand how it works. All right, I will see you all on Thursday. It's like a whole week. I will also say that the color theory, what we're going to cover on Thursday, is, I think, arguably the most difficult thing we're going to do. So you're also getting a time off to really prep that up. A lot of people might be thinking it's like when we're going to talk about algorithms. The algorithms are easy, especially since we don't have to. Some of us can understand the math. Other ones, it's just going to be like, I know I can do this with this algorithm, but color is super fucking trippy. It's very, I got to be honest, is the thing I probably understand the least. So you've got some difficult content to work through, and then some very simple things you can do to just scoop up some course credit. All right, let me know if you have any questions, and other than that, I will see you on Thursday. Yep.
Did we make that